Hi, my name is Guang, 12 years old. For this lesson, we'll be continuing on with techniques and applications for definite integration. For this lesson of definite integration, we'll be continuing on with double integration, where we'll have to use a double integral to determine the volume of the region that is between the xy plane and fxy equals to 2 plus cosine x squared, and is above the triangle with vertices 0, 0, 6, 0, and 6, 2. So over here, let me just explain the diagram a bit. So you can tell that the base is basically a triangle. Also, for this part, what we have here is that so the rooftop tiles, they are more or less curvy and alright. So imagine that there's a house with the rooftop tiles, but it is flat. That's the first thing. And then second thing, over here for this part, it is basically shaped like a triangle if you look at the xy axis. Okay, so over here, the xy plane is always going to be a triangle. So for this part, it's just imagine a house with the rooftop tiles. Remember the curvy ones, and then cut in half, and thus the house shape they will get will probably be a triangle and all. And what the coordinates for the triangles, different points are basically 0, 0, 6, 0, and 6, 2. Naturally, these points will go according to x, y. So x will be 0, so the first coordinate will be x equals to 0, y equals to 0, second coordinate x equals to 6, y equals to 0, and third coordinate x equals to 6, y equals to 2. So now we can integrate now that we have known about this. So over here for this part, because the z, it's the part that's just straight up without any, so it's like over here for this part, what we'll get here will be 2 plus cosine x squared dx dy. But which one are we going to integrate it according to first? So obviously you cannot integrate it according to x first, even though it is definite integration. So if it's indefinite integration, you most definitely cannot hot solve this, but since it is definite integration and it's double integration, we possibly can solve this. So now how we are confirmed that we are going to integrate with respect to y first. But now that we are confirmed that, we need to know the boundaries. So if you're looking at the xy plane, it's going to be something like so over here our first coordinate is 0, 0, right? And then our second coordinate will be somewhere like over here 6, 0. And then after that, over here for this part, what we'll have will probably be somewhere like this part, where y is equals to 2 and x is still equals to 6, thus having the point 6, 2, and thus our base, if we look up or down the whole volume or just the x or y plane, the shape of the triangle will be somewhat like this. Okay, so now that we have known about this, since we are integrating with according to y first, so we must know what y is equal to, right? So y will be equals to, so if we realize for this part how x is 6, y is 2, that means y is equals to x over 3. Okay, alright, now that would just, so now that we know that it is y or x over 3, so we will now know the boundary for y, which is from 0 to x over 3. And now for x, it will simply be from this part to this point, from 0 to 6. And now we can integrate it. So when we integrated our normal integration over here, since this part doesn't have anything to do with y, so what we'll have is 0 to 6, 2 plus cosine x squared y from 0 to x over 3 dx. And then after that, if you substitute 0 inside, it will always be 0, so you can just ignore that. And now that you have gotten this part, what we're going to have is x over, so we're going to have 2 over 3x dx plus 1 over 3 x cosine x squared. And now that we have this extra x over here, if we place this part inside, we'll be able to get our x squared, and thus we'll be able to integrate it. So we can already integrate this straight away, which will lead us to 2 over 3 times half x squared from 0 to 6. And then for this part, you put this inside, and integrating this will give us a 2 over, you have another half. So when you get another half, what you're going to get is 1 over 6, and here cosine x squared dx squared, basically being cosine x dx. Okay, and now these two you can simplify, and you will get a 6 squared over 3 plus 1 over 6 sine x squared from 0 to 6. So for this part, the 6 squared is basically 36, right? So when you simplify, you're going to get a 12 plus, your sine 0 is 0, so when you substitute 0, it is useless, so you can ignore it. So when you substitute 6, you're going to get 1 over 6 sine 36. And that is our result. Well, the reason why we cannot solve it is because that sine 36, you just cannot solve it. Okay, so now that we are done with this part, so let me just quickly explain. So for this over here, our double integration, and so for the double integration, you can use it even in triple integration and all those. So for this part, if you're finding volume and all, you can actually use double, single, or triple depending on your choice. So for this part, sure, you can try to use triple integration. It's just that the result will just be the same. Okay, so over here, so what I've drawn over here is just how you see the x, how you see the base, what the base and the top part of the volume is like, basically the x or y plane. So for this part, well, on the other hand, when we have the z part, there will be the 2 plus cosine x squared, which is basically the curly one. And thus over here we can just straight away integrate since, and so for the z there isn't really that much of a change. Okay, so over here that will be mainly it for this lesson. Last but not least, thank you for your watching.